Hello, this is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, VoLTE Reality Check. How long will your legacy network need to live? Presented by Sonus. Our presenter today is Bill Welch, Senior Product Manager at Sonus. At this time, I'd like to pass the presentation over to Bill.
Thanks, Kyle. Hi, folks. My name is Bill Welch. I am a Senior Product Manager for Signaling at Sonus, and I'm here to talk about a VoLTE Reality Check. How long will your legacy network need to live? So to start out, let's first take a look at what challenges operators face. At the highest level, they have to introduce new technology to kind of keep pace with services and technology needs. So here we have VoLTE, Voice over LTE, video broadcast, virtualization, NFV, and FDN. These are all new technologies that are coming to bear now for operators. They have to face basically explosive growth of their LTE traffic and diameter. And so the LTE subscriber growth leads to diameter growth. Policy, as far as policy charging, also drives diameter growth. And then new technologies like VoLTE and video broadcast are ever increasing that diameter signaling traffic. They have to do this explosive growth while also maintaining legacy. So in the last couple of years, the last, say, 5 or 6 years, there's been a fairly significant vendor attrition on the SS7 network. But faced with that, there also is continued growth in 2G and 3G subscribers. And, you know, as always, the subscribers now expect an always-on experience, and that is coupled and pressed up against flat revenues versus ever-increasing OpEx. And then if you have any signaling problems and signaling outages, they're essentially media-worthy and potentially regulator-worthy, where you will face bad press events out there in the world, or you may have become under regulator scrutiny and potentially face some fines. In the upper right-hand corner, we're showing you projected growth of the chart coming from the GSA on 2G, 3G, and 4G subscribers. As you see, even now, in the green at the top, 2G is actually quite small as compared to 4G is quite small as compared to the 2G and 3G subscribers. And you see the ever increasing amount of LTE networks deployed. So in those numbers from 2009 to 2015, it's going from 2 to 638 networks that are up and running with LTE. And so we had really explosive growth in sort of the 2011 and 2012 timeframe. And then VoLTE is really just kind of coming to bear really 2014 and 2015 and just starting to take off. In the lower right-hand corner, we show you the diameter hockey stick that has been presented many times. And what this is expected revenues for diameter solutions and their associated licenses. And that is increasing at the same rate and even greater than 4G LTE subscriber growth. So let's take a look at some of these numbers in a little bit more specific information on the next slide. So certainly we have tremendous growth with both VoLTE and LTE, but there's that ever but question that emerges. So LTE actually is the fastest adopted wireless technology by far as compared to older technologies like 2G and 3G. And there is an expected 64% of coverage by 2020. But it begs the question of what about the percentage of connected? So even by the time of 2020, 5 years from now, only 28% of the overall connections, mobile connections, will be on LTE. So what about those other 72% connections? Those are going to be on 2G and 3G. And let's take a quick closer look of how that evolves. So customers have choices. So here you see a big pile of phones, a fair amount of them legacy ones, but these are also in use today. And so that is your legacy SS7 voice network, where you have circuit-based voice and you have circuit-based SMS. And slowly but surely, some of those customers are migrating over to either OTT OTT offerings out there in the world, or voice offerings, or very commonly both. So it's very rare to have a mobile phone subscriber without basically some type of voice plan or voice capable option. Data only with regular phones or smartphones is really somewhat limited. So as customers migrate, you need to be prepared. And the question is how quickly are these customers going to move over to either an OTT player or potentially over to a HD voice? So the natural progression is for an operator perspective is to have them migrate from the circuit-based SS7 network over to a VoLTE offering. And as we saw in the previous slide, VoLTE is really just starting to take off here, and LTE essentially had a 5-year head start, and by 2020, only 28% of the customers will be connected via VoLTE. So how long will it take for all those customers from the SS7 network to move over to a complete, IP-based voice over LTE? It's going to take quite a while. So we have a poll question here coming up, and just asking you as operators, when do you think you'll retire your SS7 network? Will it be 2020? Will it be 2022? 2025, 2030, or beyond? So these are potentially long-lived networks. So as you see here, we have a few folks that are looking at 2020 as potential retirement of their SS7 network. A few more around 2022, but it looks like at least a third, a little bit over the third, are looking at 2025, and many customers, about 20% are looking at 2030, and even 15% are looking at 2030 and beyond. So these are considerably long-lived networks. And I'm trying to debunk here, do a VoLTE reality check of how quickly customers will move over, from a subscriber standpoint and an operator standpoint. And as you can see here, these, as expected from my end at least, these poll numbers kind of indicate that we're not going to get to VoLTE, a fully VoLTE network, anytime soon. And so thank you for that information. So moving on. So let's talk about your STPs in your network to support that SS7 network. You have to ask yourself, what era are basically your STPs from? And so on the left, we have the TDM-based STPs. And those are designed, for either low capacity or high capacity TDM. And then in those solutions, they may have a limited backplane capacity to do 2 upgrades, either of the chassis and or the line cards. They could be expensive and or a complete forklift upgrade, which is a replacement. And you face various issues of end of life, end of product sale, or end of service. And potentially with those 1990s based STPs, you may have RoHS worries, which are essentially requirements for electrical equipment to not have lead-based components. And so maybe a consideration from a vendor to stop shipping or stop making available certain parts or line cards because they're not RoHS compatible. And so this may not be a direct impact to you, or maybe consideration for the telecom vendors, but eventually downstream it impacts you because that's maybe the forcing function to then push for end of life. In the 2000s, we had IP-based STPs, and so they're generally TCA-based or micro TCA-based. It easily allows you to migrate from, say, TDM to IP interconnect, but it's not quite future-proof in the NFV world, and it's certainly not virtualized. Then off to the right, you have kind of a future-proof option with the virtualized, and it's essentially future-proof from an OS and hypervisor standpoint. If you do sort of an NFV or hypervisor-based solution, you can do consolidated hardware sparing, or rather than having purpose-built hardware in a TDM-based STP or an IP-based STP, you can use generic off-the-shelf, common off-the-shelf servers from the likes of HP or Cisco or Dell or whoever it may be. And so we really see you need your vendors to have a way to migrate from TDM to IP and then eventually step up and have a virtualized option. And you want to support things like TDM from a hypervisor standpoint. VMware is another popular hypervisor, and then move towards integrating OpenStack to then enable that infrastructure capability and to slowly march towards a full NFV solution. So moving on, what's the total cost of ownership of these different FCPs? With the TDM base, you generally have high interconnect costs and transport costs to support that TDM traffic, and just from a sort of a cost of goods, you may be using you're often using either very legacy Intel-based processing or non-Intel-based processing. And if you are using Intel-based processing, you're getting potentially every 5 or 6 revs from Intel, you're getting potentially a board update versus moving over to and kind of following the cost curve that Intel is coming out with new processor families every 18 to 20 months. You get a better economic advantage, particularly on using Ethernet and IP interconnect with an IP-based TDM, and with the TCA micro TCA chassis, you certainly have you're better able to ride the economic advantage and cost curves of newer, faster Intel processors, and of course the ever-present power and cooling sort of variables. And then on the right-hand side, you have the hypervisor base, which is definitely following the exact curves. Again, that every 18 to 20 months. So you have ever-improving cost curves for both Ethernet, IP, and essentially the Intel platforms. And you also have the elasticity capabilities of a hypervisor-based and NFV-based option, where you can really scale up and scale down if needed, and much quicker versus kind of building it and potentially sitting on those assets for long periods of time. So moving on to the next slide, let's talk about NFV itself. So NFV is Network Function Virtualization. This is where you're taking network functionality. You're essentially focusing on software and having a software-only solution, laying that on top of common off-the-shelf hardware. You're using a hypervisor to create some abstraction, and then you're potentially having kind of full elasticity of basically being able to kind of grow and shrink at a much faster clip. So which phase of NFV do you desire? You have sort of hardware separated, which is you may be using a software-based solution, but it requires runs on a Linux kernel, and then is on common off-the-shelf hardware, but it's still not virtualized at that point. You may have, from a hardware sparing perspective, you may have specific hardware that it only runs on to spec, and you don't necessarily get that common hardware kind of sparing economics coming to play. Could be phase 2, where it's essentially on a hypervisor, where you've created via the hypervisor that abstraction between the hardware and software. So it's much easier to move from server to server, and if there's a need for a hardware update because the hardware has gone end of life or is no longer powerful enough, you can swap it in sort of at your desire. You could go and follow the cost curves very aggressively with Intel, basically swapping servers in every say 16 to 18 months or so, or you can ride it a little bit longer as needed. Phase 3 is fully elastic, where you get the capabilities, particularly templates and the ability to automate a lot of this stuff regarding configurations. And this is basically gives you the ability to scale up and scale down. And then the last phase, which we're currently exploring, is functional decomposition. So what does this mean? And what does this mean to you? So today, within the FTPs and diameter solutions, you get sort of a kind of a piece of application, and it's all basically integrated and built together. And you have certain scaling properties that of individual kind of subcomponents. You may look at, you may have a certain use case in mind or a particular business need where the scaling kind of characteristics don't quite meet your needs in a particular subfunction. So is it possible to kind of decompose that in a way where you're separating subfunctions, where you have the high scale subfunctions that you need spread across multiple virtual machines, and the low scale sort of components that you need in a much smaller number. And so these are the things that you should think about and evaluate depending on your particular network and overall kind of call flows. And as noted here at the bottom, each phase, starting from left to the right, is a different capability being added, but they're layered and build upon each other. So essentially, I think of it as the big fish off to the right and the small fish off to the left. Phase 2 is eating phase number 1 and consuming it. Phase 3 is eating phase 2 and consuming it, and phase 4 is ultimately eating everybody along the way and has those capabilities. Phases could be skipped by a particular vendor. You may go straight from phase 1 to say phase 3, or to skip over phase 1 completely, and that could be done either by operators or the vendors themselves. So let's talk about elasticity a little bit more. So what type of elasticity do you require? So vertical is on the left here, and this is basically where you take a VM and it may have a particular VM container size. Say it's 4 virtual CPUs and 5 gig of RAM, and maybe a couple of interfaces from a scaling standpoint. And you grow that up to be sort of a bigger version of that. So you go from 4 to 8 maybe virtual CPUs, maybe add some additional interfaces in order to have additional throughput on the Ethernet side, and maybe some additional memory depending on memory footprint. And so that's a kind of a vertical type elasticity. You have horizontal, which is actually off to the right here, where as you grow and shrink, you're either adding or removing VMs of the same or close to same container size. Or depending on your network operations and potentially the hardware underneath that you have there, you may like and want both. So and then I kind of have a provocative question here at the bottom. Is diameter really different than SS7? And so we're moving here to our poll question number 2, and just asking you next up, which phase of NFV do you desire? All right. Not really a surprise for me on this end. This is what I've been hearing from our customers. So hardware separated at 13%, relatively low runner. On a hypervisor is next up as far as phase 2. And then at least almost 50% of you responded looking for fully elastic, and that's really when the full weight and capabilities come to bear from a fully kind of NFV solution. And there are, I guess, certainly some interest, at least almost a quarter of you looking for a functional decomposed. So that's an interesting variable there that I should think about some more. So let's talk about going back to diameters, where we started, and the operator challenges. So we're hearing from customers that they're looking for a combined solution of both diameter and SS7. And they're looking at for a number of reasons. They're looking for, they're seeing their networks, evolve rather than just completely transform. And these networks are going to live overlapped, as you saw, for many, many years. You had LTE starting to be introduced in say 2010 to 2011, and we're via the poll and which I agree with that poll. Many customers are looking to at least 2025 or 2030 for the SS7 network. So that's a good long time for these networks to be running in parallel. And so customers are looking for a way to leverage these assets as their networks and their subscribers change from a sort of an SS7 dominated network, and slowly over time that traffic and those subscribers are moving over into the diameter and all IP world. You want to obviously be able to handle explosive LTE and diameter growth, and also maintain the legacy services along the way. And you'll have to do this under again that flat economic model. Subscribers may be growing, but revenues basically be remaining flat, and operations are basically ever increasing. So these are always a pressure here. So if you look off to the right, this is the Sonus portfolio for diameter and SS7 signaling. As you see here, we have a couple of options in the middle. We have the DSC 8000 in that small box near the bottom middle. That's essentially our ACCA chassis based system, ideally designed for both TDM and IP interconnect on the SS7 side, and a fully capable diameter solution on the LTE side. Those DSC 8000s can be configured in stack into a single shelf there, or essentially a single rack in sort of a multi-shelf configuration. Underneath that configuration, you essentially have a single managed system, and that single managed system can handle both diameter or SS7. And then in the last back in 2014, we came out with our SWE option, or DSC SWE, or software edition. That's essentially where we've taken the software off the DSC 8000, uplifted it, and then layered it on top of TDM and VMware hypervisors. And so those two solutions are a portfolio, or three if you think it in a multi-chassis sense. And they can handle the core router capabilities on the diameter side, DRA for stateful IPCAN session routing, load balancing from an OCS or HSS, and then handling the carrier edge for either interconnect with roaming providers or actually being used by IP exchange carriers to perform the same function or to interconnect those roaming partners. And then subscriber location function, which is a capability and situation where you have multiple HSSs that are divided up either because of scalability issues, regionality issues, regulatory issues, or just for redundancy issues. And you have your subscribers broken up in some way, either odd even numbers, particular ranges, or completely random. And you have to have an extra subscriber database to figure out where the full profiles are at for a particular subscriber. Then off to the right, we have our SS7 part of the solution, core FTP functionality, including number portability, global title translation, advanced routing, and virtual FTP capabilities, signaling gateway functionality to transition from TDM to IP, and then IP edge sort of scenarios where you're doing basically things like point code emulation. So these are solutions we have out in the market, and we're trying to directly address those operator challenges. I want to point to something next regarding a white paper that we put out here. So we were talking about the SS7 evolution and how the intersection of virtualization and signaling transfer points helps reinvigorate FTPs. In the last, say, 5 or 6 years, we have a number of FTP vendors that have basically end of sailed their products, and they're probably approaching end of support. And you haven't really seen much new vendors coming in and replacing those. So it's becoming an ever-dwindling kind of pile of vendors, and you want to make sure that your vendor is there in the long term. And so we feel that the injection of NFV and virtualization sort of help reinvigorate the marketplace for FTPs and SS7, and then we definitely plan to be here for the long term, into that 2025 and 2030 timeframe in order to support customers that, as they migrate. So take a chance, take a look if you have a chance to download our white paper, and that is the conclusion of the slides.
All right, thanks, Bill. This is Kyle again. So we've had a number of questions come in, and everyone in the audience, if you have any questions at all, please submit them via the control panel, and we should have some time to get to them. So, Bill, the first question we had come in is virtualized STP product available today?
Yes. Back in November of 2014, we made that product available, our first release of DSC FWE. And we're following that up with another release here coming up in the next couple of weeks to add some more capabilities and functionality. And as you know, a lot of these it takes a long time for operators to first procure and then implement capabilities like this in their network. And so we're just starting to see the first real customers move out of kind of proof of concepts from their labs right around now and actually moving into production. And so we should be able to come back at a later point and talk about customer success stories here in the coming quarters.
Okay, great. Another question we had is, could you go into a little more detail as far as a functional decomposed phase and why one would choose to roll that out?
Sure. So, for example, there may be fairly complex call processing, say in gateway screening, that needs to be done, and the rest of your network could be relatively simplistic from a call forwarding standpoint. You may have the same situation on the diameter side. You may have, for example, DEA functionality, which is diameter edge agent, where you're doing topology hiding capabilities and call routing there. Those might be scaled completely different from, say, core routing functionality, or essentially, say, DRA capabilities for safer routing with a PCRF. So we're evaluating and looking at potentially decomposing these. You can either leave them glued together or pull them apart, depending on operator need, on one VM or separated. And then you can independently scale them up as needed. So you could have, potentially, if you have a really large core network and not a lot of roaming, your GEA could be really small, but your core routing could be, really quite large. All it depends on kind of the economics, your business models, and your interconnect with other providers.
Okay, great. Next question we had come in is, what if someone has a TDM interface to support? How could they work with that?
Sure. So today in our product, we don't have TDM interface support for our DSC FWE. We are evaluating ways to be able to do that. The key there is, if we did bring that capability to market, we would want to do it in a clean way for virtualization, where we don't end up with a whole kind of hodgepodge of different sort of scenarios that need to play out. For example, you have lots of different hardware that's out there. You have potentially on the hypervisor, you'll have the host OS that's laid on there. It may have different versions of that, and you may have different hypervisors that lay on top of that. And so we'd really like to do it in some sort of clean way. We've yet to find that sort of silver bullet to get there. If we do find it, and/or we get some support maybe from the hypervisor side, we'll bring that and introduce it. But until then, we have the DSC 8000, which certainly supports the TDM interfaces, and that particular chassis-based solution will be available for many, many years to come. Customers we talk to, depending on their life cycle of their end switches and configuration of those, and when they've installed them, and maybe potentially when they've upgraded them and or swapped them out, you either have customers who are say 90 or 95% TDM, or you have the other end of the spectrum today, where you have customers that are like 5% TDM, and where the other side of it is IP. So until those customers at the 95% of TDM either migrate and or kind of change there, we will continue to have a TDM-based offering out there in the world.
It's really interesting. So the next question we had come in is, How will the performance be on a virtualization platform compared to a standalone server?
Sure. So the virtualization layer will introduce some restrictions and/or percentage difference there. It's not that significant. You have to think about virtualization as where it is in its life cycle. So virtualization really started about 10 years ago in the IT world, and since then they've certainly made a whole lot of improvements, not only in the individual hypervisors, but also just competition-wise. It used to be, there's maybe only one or two games in town, and now pretty much every software house there in the world has a hypervisor. So the likes of Microsoft, Oracle, VMware, open source ones like KVM, you name it. There's various hypervisors out there. So these things have come a long way. And to more specifically answer your question, we generally see, call it a hypervisor tax, if you want to term it that way, somewhere between, say, 5 to maybe 15%, difference. We're in our application for both the FTP and the diameter, we're not a very throughput-oriented sort of scenario. We have high volumes of tens and maybe hundreds of gigs of traffic moving through an NFC box. We really have small amounts of traffic, but obviously very critical traffic from a latency standpoint. So there is consideration there in order to make sure that everything functions possible. And what we do is a fair amount of rigorous testing to make sure that the solutions we're coming up with actually meet the operator's needs, both from an uptime standpoint, performance standpoint, and so generally, what to go back to. And answering your question a little bit more, generally our DSC 8000 blades are, from a performance standpoint, are generally equivalent to, say, an older generation HP box, say like an HP Gen 8. Gen 9s have been out for maybe about 6 to 9 months or so, somewhere around there. And they're already talking about Gen 10s. As you see, we're on the Intel side, we're very much on the constant kind of flywheel of ever updating processors.
Thanks, Bill. So next question we had come in is, how long do you expect the SS7 network to survive?
So at a minimum, we're looking at 2025 at a minimum, and so the maximum we think is basically 2030. In the worldwide, there's been a significant movement of subscribers outside of the U.S. To OTT offerings, either them being free or close to free, where a fairly significant amount of the operator's traffic is basically moved to data, and essentially data services via OTT. But even with that, with pretty significant 70 or 80% kind of usage, overall usage of these services, you're still not seeing customers clamoring for and or trying to cancel their voice package because they see those OTT players as sort of best effort and may not work in all scenarios, may not have coverage, may not cover basically sort of 911 type capabilities. And so to push back against that sort of best effort free world, we see the arms race coming up with operators where they're really pushing heavily and aggressively as possible to come up with VoLTE-based solutions, where you're getting a much higher quality call. Back a few years ago, before I had gray hair, the call quality was radically different. Between a cell phone call and essentially like a landline call. The landline call was much clearer, less likely to drop in quality there. VoLTE is essentially allowing that to happen. We could do a whole, and there has been many webinars and opinions out there regarding VoLTE as far as its capabilities. But this is, the operators, the mobile operators in the world, really need to, over time, the next, say, 5 to 10 years, really arm themselves with VoLTE in order to kind of push back against that threat on the OTT side.
All right, thanks, Bill. That's about all the time we have for today. I want to thank everyone for attending today's webinar, VoLTE Reality Check. How long will your legacy network need to live? Presented by Sonus. Again, our presenter today was Bill Welch, Senior Product Manager at Sonus. Thank you, Bill.
Yep, thanks, Kyle.